Good morning, respected sir. This is Vaibhav Sharma, and we are Group 3 here to present our video commentary on the topic Basics of Computer, Hardware and Software. Our Group 3 comprises of myself, Pratmesh, Yash, Prasan, and Ishar. So the topics we'll be covering in software would be Windows OS, Mac OS, Linux, and Ubuntu. And on the other hand, in the hardware part, we'll be covering CPU, RAM, and the generations of storage. So here is Pratmesh to introduce us to the world of software.
So this is Prathamesh, and I will introduce you to the world of software. So in this presentation, we will provide an essential introduction to the field. We will cover topics like basics of software development, including types of software, and give a slight introduction to operating systems. So what is software exactly? Software is nothing but programs, applications, and data that establish full foundation of a fully functional computer. There are many types of software. The three prominent ones are applications, firmware, middleware. Applications are specific programs that are used for specific tasks. Firmware is a type of software that is permanently stored in hardware like microprocessors. And middleware acts as a bridge between software applications and allow them to work in a synchronized manner. So how exactly does a software works? So lines of code produced in programming languages like C++, Java, and Python, and many other make up software. These instructions are written by programmers to specify how the software will operate. So here is Izhar to give a slight introduction to operating systems.
This is Izhar. I'm gonna say about operating system. A computer's hardware is managed and controlled by software called an operating system, which also acts as a platform for other platforms to run on program. To allow users and apps to communicate with the computer, it manages variety of functions, including memory management, file system management, device management, process management, and user interface. It also guarantees system stability and security. Examples are Mac OS, Windows OS, Linux OS. Here is Vaibhav Sharma to introduce about Windows OS. Windows OS, unveiling the powerhouse of productivity. As an introduction, Windows is a family of graphical operating systems developed by Microsoft. It is the most popular operating system in the world with a market share of over 70%. Windows is used on a wide range of devices, including desktop computers, laptops, tablets, and even smartphones. It is a popular choice for businesses and individuals alike because it is easy to use and has a wide range of features and functionality. Talking about the user interface, the user interface of Windows OS enhances efficiency and workflow. Customizable features and a familiar layout empowers users to navigate with ease and maximize productivity. Some of the advantages are simplicity, consistency, accessibility, compatibility, and customizability. Talking about the security features, the advanced security protocols helps safeguard our data and operation. Windows OS offers a robust security feature such as Windows Defender, BitLocker encryption, and firewall protection. Windows Defender is a built-in antivirus and anti-malware program, while BitLocker encryption is a full disk encryption feature which helps protect the data in the hard disk from unauthorized access, while firewall protection is a security feature that helps Windows devices from unauthorized access through the internet. Collaboration tools such as Microsoft Teams, SharePoint, and OneDrive. Microsoft Teams is a unified communication and collaboration platform that brings together chat, calling, video conferencing, and file sharing into a single application. While SharePoint is a web based collaboration platform that allows teams to share and manage files, documents, and other resources. We all know OneDrive. OneDrive is a cloud-based storage service that allows teams to share, store, and share files online. So here is Pratmesh to tell us about the highly efficient macOS.
So now we will get acquainted with the elegant and efficient macOS. In this section, we will be exploring the evolution and advancements of macOS throughout the years, and also be getting a hint of what macOS stands for. So for the history, the graphical user interface era for personal computers began in 1984 when Apple released the first Macintosh with its initial system software. After going through a number of revisions, Mac OS 9 brought about improvements in terms of both functionality and performances. For the Mac OS 10, a full redesign of the Macintosh operating system, Mac OS 10 was released by Apple in 2001. Because of its Unix-based architecture, it offers improved security, stability, and cutting-edge functionality. Apple kept and Apple kept working on the operating system, releasing updates that improved performance, user experience, and integration with the company's growing range of products. So for the features of macOS, it has a very user-friendly interface. macOS offers an intuitive and visually appealing user interface with features like Dock, Finder, and even familiar Apple menu. Security. Apple places a strong emphasis on security with features like Gatekeeper, File Vault, and the T2 security check. Continuity, seamless integration with other Apple devices, including iPhone, iPad, Apple Watch, and iCloud, allows for smooth handoff of tasks and content. Performance, macOS is optimized to run efficiently on Mac hardware, providing excellent performance and responsiveness. Now, Yash will tell you about Linux and Ubuntu.
Exploring Linux introduction to the Ubuntu operating system. Ubuntu is a powerful and user-friendly Linux operating system. In this presentation, we will explore the key features and benefits of Ubuntu, including its open source nature, stability, and vast software ecosystem. Now, what is Linux? Linux is an open source operating system kernel that serves as foundation for various Linux distributions, such as Ubuntu, Fedora, Arch Linux, etc. It provides a stable and secure platform for running applications and managing hardware resources. Linux is known for its flexibility, scalability, and robustness, making it popular choice for servers, desktops, and embedded systems. Ubuntu, a brief history. Ubuntu is derived from an African philosophy of humanity towards others. It was created in 2004 by South African entrepreneur Mark Shuttleworth. It quickly gained popularity for its focus on user friendliness and accessibility. Ubuntu is Debian-based architecture and offers a rich and intuitive desktop environment for both casual and advanced users. Key features of Ubuntu. Ubuntu offers a lot of features, including security, stability, easy to use, and vast software repositories. Its robust security measures protect against various malicious threats, while its stable and well-tested nature ensures reliable performance. The intuitive user interface and comprehensive software repositories make Ubuntu an ideal choice for individuals and organizations alike. Exploring Ubuntu Desktop. Ubuntu desktop environment provides a sleek and modern user interface, offering a seamless experience for both new and experienced users. With its customizable layout, integrated search functionality, and extensive application suite, Ubuntu desktop empowers users to work efficiently and enjoy a visually appealing computing experience. Ubuntu 22.04 LTS is the latest Ubuntu software available online. How does Ubuntu looks? Vaibhav, please go back. Ubuntu desktop by default looks like this, the latest version. And now switch. More about Ubuntu. Ubuntu can look like any type of operating system by appearance. It merely involves changing the GUI feature in the software. For example, Ubuntu is looking like Windows 8 in the example, and Ubuntu can also look like Windows 7 and Mac and or any other operating system. So that's all. Now Izhar will introduce us to computer hardware.
Hardware, a comprehensive introduction to computer hardware. This presentation offers us information about the fundamental components of computer system, including the CPU, RAM, storage devices, and peripheral devices. Central Processing Unit (CPU). The CPU is the brain of the computer, responsible for executing instructions and performing calculations. It consists of ALU (arithmetic logic unit) and control unit. The CPU interacts with other hardware components through the system bus. The speed of the CPU is measured in gigahertz, determining how quickly it can process data. Modern CPUs often have multiple cores, allowing for parallel processing. Random access memory (RAM). RAM is a type of volatile memory that temporarily stores data that the CPU needs to access quickly. It provides fast read and write speeds, allowing for efficient data retrieval. RAM capacity is measured in gigabytes, and more RAM generally leads to better performance. However, RAM is temporary storage and does not retain data when the computer is powered off. And now Prasan will be giving a detailed information about RAM.
Hello, sir. Myself, Prasan Kote. I am introducing you to the comprehensive analysis of a random access memory. In this presentation, we will delve into the importance of RAM in maximizing system performance and provide insights into optimizing its utilization. To understand RAM, Uh, it stores data that CPU needs to access quickly, providing temporary storage for running applications and process. RAM directly impacts system speed and multitasking capabilities. The capacity and speed of RAM significantly influence system performance. Higher capacity allows for more applications to run simultaneously, while faster RAM ensures quicker data access and processing. RAM utilization. Efficient RAM utilization involves managing background process, prioritizing applications, and utilizing memory optimization tools. Proper utilization can enhance system responsiveness and overall performance. Upgrading RAM can breathe new lives into older systems and improve performance. However, it's crucial to ensure compatibility with the motherboard and existing hardware components. Thank you. Continuing to CPU, our teammate Yash Srivastav will introduce about CPU. Thanks.
History. The evolution of CPU has been marked by remarkable advancements in processing power and efficiency. From the early days of single-core processor to today's multi-core architectures, CPU have continually pushed the boundaries of performance and capability. CPU architecture. The CPU is the brain of computer, executing instructions from memory. Its architecture includes an arithmetic logic unit, ALU, for mathematical and logical operations, a control unit to manage instruction execution, and registers for temporary data storage. The CPU fetches, decodes, and executes instructions in a continuous cycle, coordinating the computer's overall operation. Performance metrics. The key metrics used to evaluate CPU performance including clock speed, instructions per cycle, and benchmark scores. These metrics provide insights into the speed and efficiency of CPU in executing tasks. Parallel processing. The concept of parallel processing lies at the core of modern CPU design, enabling the execution of multitasks simultaneously. Understanding parallel processing is essential for harnessing the full potential of multi-core and hyper-threaded CPUs. Thank you.
Evolutionary milestones, unveiling the generations of storage. From the earliest punch cards and magnetic tapes to the cutting edge cloud computing and solid state drives of today, storage technology has evolved at an astonishing pace. Each generation has brought new innovations and capabilities, enabling us to store and access more data more quickly and more efficiently than ever before. Talking about the generations, for the first generation, we have the magnetic tapes. They were developed in the 1930s for audio recording and were adapted for computer use in the 1950s. Magnetic tape is a long, thin strip of material coated with a magnetic coating. Data is stored on the tape by magnetizing and demagnetizing the coating.
The second generation includes floppy disks. They were developed in 1970s as a more portable and affordable alternative to magnetic tape. Floppy disks are made of thin, flexible plastic discs coated with magnetic material. Data is stored on the disk by magnetizing and demagnetizing the coating.
Third generation hard disks. Hard disk driver are the third major generation of storage technology used in computer. They were developed in 1970s as a more reliable and higher performance alternative to floppy disk. Hard disks are rigid and become the dominant storage medium for computers in 1980 to 1990s.
Fourth generation solid state drives. Solid state drives SSDs are the fourth major generation of storage technology used in computers. SSDs use flash memory to store data, which is a type of non-volatile memory that does not require power to retain data. SSDs offer a number of advantages over HDD, that is hard disk drives, including fast access times, lower latency, higher reliability, more efficient power consumption, smaller and lighter form factor. Fifth generation cloud storage. It refers to the storage of data on remote servers accessed over internet. Cloud storage offers a number of advantages over traditional on-premises storage, including accessibility, scalability, reliability, and cost effectiveness.
For the sixth generation, future innovations, the sixth generation of storage technology is still in its early stages of development, but there are a number of promising innovations that have the potential to revolutionize the way we store data. Some of the most exciting new storage technologies include DNA storage, quantum storage, and holographic storage. So that will be the end of the presentation. We appreciate the opportunity to share our insights on this topic. Thank you very much.